Imagine a fuel so powerful it could solve our energy crisis, and so clean it produces almost no radioactive waste. This isn't science fiction, it's called Helium-3. For billions of years, the sun has blasted Helium-3 into space. Earth's magnetic field shields us, but the moon has no such protection. The lunar soil is saturated with Helium-3, a rare isotope that could revolutionize energy. On Earth, Helium-3 is almost non-existent, but the moon may hold over 1 million tons, enough to power our planet for thousands of years. Helium-3 is the key to nuclear fusion, the process that powers the stars. When fused with deuterium, it releases immense energy, with no greenhouse gases and almost no radioactive waste. Mastering Helium-3 fusion could power our cities, industries, and even space travel. That's why we're returning to the moon, not for flags, but for the future of energy. This is the new gold rush, a cosmic one. The prize isn't gold but the power of the sun stored in lunar dust. The moon is no longer just a destination for exploration, it's a source of hope. The moon's resources could power not just Earth, but our journey to the stars. The moon is calling, and this time, we're listening. A new space race is underway, but this time the prize is lunar resources. The United States and China are the main competitors, each aiming to secure the moon's riches. The first to mine Helium-3 could gain economic and strategic dominance for decades. NASA's Artemis program plans to build a permanent lunar base, with private companies as key partners. The American approach is a public-private partnership, unleashing commercial innovation on the moon. Meanwhile, China's Chang'e missions have landed on the far side and returned samples. China, with Russia, plans an international lunar research station, a direct competitor to Artemis. China's method is state-driven and methodical, building capabilities step by step. Both nations are investing billions in rockets, landers, and mining tech. The race is accelerating, with every launch raising the stakes. This isn't a Cold War contest, it's a 21st century resource race. Boardrooms and labs are as important as government agencies. The moon is the new frontier for economic and technological supremacy. The winner will shape the future of space industry. The stakes are higher than ever. The moon's resources could tip the balance of global power. The world is watching as nations compete for the ultimate prize. The moon awaits its new pioneers. Sometimes, the biggest leaps in space come from companies, not governments. Bluefors, a Finnish cryocooler company, just signed a $300 million deal with Lunar, a US startup aiming to mine Helium-3 on the moon. This isn't just business, it's a signal that commercial lunar mining is real and imminent. Bluefors cryocoolers reach temperatures near absolute zero, crucial for extracting Helium-3 from lunar soil. Interlune's plan. Media Group, simulated lunar regolith being heated in lab, soil sample in high-tech laboratory, technician handling moon dust analogous stock could distribute equally, heat regolith to release gases, then cool and separate out Helium-3. The deal funds the development of these specialized machines, technology never before used on the moon. Interlune, founded by space industry veterans, believes robotic harvesters can make lunar mining practical. This partnership marks the first major commercial contract for lunar resource extraction hardware. It moves the conversation from "what if" to "how soon." Serious investment is now flowing into the lunar economy. While governments build rockets, companies like Interlune and Bluefors are building the tools for lunar industry. This is a bet that the moon's resources can power our future, and that private enterprise will lead the way. The era of commercial lunar mining has begun. The race to unlock the moon's energy is on. Mining the moon is thrilling, but incredibly tough. Helium-3 is more common on the moon than Earth, but still extremely diffuse. To get just 1 gram, you'd need to process over 100 tons of lunar soil. That means fleets of robotic miners, working non-stop in a harsh environment. The moon's surface swings from boiling hot to hundreds of degrees below zero every 2 weeks. Lunar dust is sharp, abrasive, and gets into everything, damaging machinery and risking astronaut health. Building reliable equipment for a vacuum and low gravity is a huge engineering challenge. If something breaks, repairs are costly and slow. Powering the operation is another hurdle. Solar panels only work during the 2-week lunar day, and storing energy for the long night is tough. Small nuclear reactors are an option but bring safety and political issues. Every aspect of lunar mining is a puzzle: energy, machinery, logistics. The cost of failure is astronomical. Solving these challenges is the first step to harvesting lunar energy. Engineers and scientists are racing to make it possible. The moon's riches won't come easy, but the rewards could be world-changing. The quest for Helium-3 is driving a bigger vision: a self-sustaining lunar economy. Companies are eyeing not just exports to Earth, but using lunar resources on the moon itself. Water ice found in shadowed craters is a game-changer. Water supports life, grows food, and, split into hydrogen and oxygen, becomes rocket fuel. The moon could become a refueling station for deep space missions. Blue Origin and SpaceX are building the rockets and landers to make this possible. Blue Origin's lander targets polar ice. SpaceX's Starship aims to carry cargo and people. Mining helium-3 and extracting water ice could power and sustain lunar industry. Solar arrays or nuclear reactors could provide energy for both mining and life support. Water supports crews and fuels rockets, enabling transport of helium-3 to Earth or beyond. It's a cosmic bootstrap, using lunar resources to build a spacefaring civilization. The synergy between helium-3 and water ice could transform space economics. By using what's already there, we can lower costs and open the solar system. The moon is the first step toward living and working beyond Earth. The lunar gold rush is full of promise, but also risk. Getting to the moon is still staggeringly expensive. Mining tech, power systems, and transport will cost billions before a single ounce of helium-3 is produced. Will the market justify the investment? No one knows. The actual amount and accessibility of helium-3 is uncertain. Our data is limited. Companies could spend billions only to find barren soil. Large-scale mining could alter the moon's pristine environment in unknown ways. We must avoid repeating Earth's environmental mistakes. Technology is still unproven. No one's run a mining operation on another world for years at a time. Machines must work autonomously, with little chance for repair. The dream is bold, but the engineering is daunting. The lunar frontier will not be conquered easily. The next decade will decide the moon's future. NASA's Artemis and China's Chang'e missions will scout the lunar South Pole, searching for water ice and helium-3. These missions will test extraction tech and gather vital data for industry. Success could trigger a wave of private investment and rapid expansion. Failure could slow progress, leaving the moon to government programs for now. The race is about more than energy or profit. It's about humanity's future. The moon could be our first off-world outpost, teaching us to live sustainably beyond Earth. Technologies developed here will pave the way to Mars and beyond. We stand at a pivotal moment, looking at the moon with ambition. The next giant leap is for all humankind. The moon's resources could launch us into the cosmos.